Hi guys, good morning. Ki hal chal? Sab changa si? I hope that you guys are good. Let's move on to this problem. It's interesting, good, real life use case problem. Let's see. Minimum cost for tickets. It is saying that you have planned some train traveling 1 year in advance, which means, okay, I'm planning for the next year. The days of the year in which you will travel are in the integer array called as days. And each day is an integer from 1 to 365. Cool. So it can be 1, 2, 3 up till 165. Cool. The train tickets are sold in 3 different ways. One way is a 1-day pass, which is sold for cost of $0. Let's name it as $1. Like not $1, but cost of $0 is the cost of 1-day pass. Cost of 7-day pass, which means I can travel 7 days consecutively with this 7-day pass by the cost of 1. I can travel 30 days consecutively by the cost of $2. See, when you have a pass, you have the pass validity, which means, okay, I have this pass for 7 days. Any day I want, let's say I travel 2, 3, 5. So it is within the range of 7, right? So if I have a 7-day pass which I bought at 2, so I can travel up till 8, which means I can travel any day 2, 3, 4, 5, 6, 7, 8. So I can travel 7 days. It is the meaning of a pass. Cool. No worries. What it is saying is that return the minimum number of dollars you need to travel every day in the list of days, because list of days is what you have planned to travel on, right? And you have these 3 passes. You are at home planning a trip. Now you want, okay, which pass I should take for which day and what would be the best. Let's see this example pretty carefully. So if we look at this, okay, we have the days, we have the cost. So we have 3 passes. So let's say if I'm standing at the particular day right here, I'll think, if I'm standing at the metro station, so I'll think, okay, shall I buy pass 1, which means the pass for the day, for the 1 day, pass for these 7 days, or pass for 30 days. I'll think all these 3 things. So let's think manually, like by writing down. If I'm standing here, I'll think 3 options: 1-day pass, 7-day pass, and a 30-day pass. Okay, if I choose a 1-day pass, if I choose a 7-day pass, if I choose a 30-day pass, if I choose a 1-day pass, so 1 day is gone. Okay, 1 day is secured. Now I have to worry about next remaining days, which are from 4 up till this last, which is 20. So I got this cost. Now my remaining part which I have to think about is 4 to 20. Okay, if I think of the 7-day pass, okay, if I think, okay, if I'm standing at the 7-day, now my rest of these 7 days, which means up till from 1 to 6, 1, 2, 3, 4, 5, 6, 7, it's all secured. Why? Because I bought a 7-day pass. So now what I have to worry about next will be nothing but 8 to 20, which is this. If I buy a 30-day pass at the first day itself, so I guess my whole month is secured. And according to it, the last date was 20 and first date was 1. So my whole 1 to 30 is secured. So I can say I can buy a 30-day pass and I don't have to worry about anything else. Cool, but still the problem is not complete, right? You bought the first day pass, but what about the remaining? You have to think again. Now let's say you bought this pass, but you are standing right here right now at 4. Still you will again think 3 things: 1-day pass, 7-day pass, or 30-day pass. Confusion, right? Let's see. So if I again buy, see, if I'm standing here, now my new problem is, okay, I have to think about from 4 to 20. The new problem is, should I buy a 1-day pass? If I buy a 1-day pass, okay, again a 4 is gone. I'll add the cost in the existing cost, because existing cost I have. I'll add the cost of a 1-day pass because I have bought a 1-day pass again. And the remaining will be 6 to 70, which is the remaining part. Cool. What if I had bought a 7-day pass, which means I had bought this 7-day pass? So I am secured for the rest of the 7 days, which means from 4 to 11 I'm secured. Up till 8 I am saying, okay, I have to travel. So after 11, which means if it would have been 9 or 10, so I would have also been secured. But here in this example, after 11, it's directly 20. So I have to worry about next is 20. But still, I'll add the cost of the 7-day pass in my existing cost, which I have been so far. Other option was buy a 30-day pass. So if I'm standing at 4, I just buy a 30-day pass. My whole rest of the trip is secured. Okay, I'll add the existing cost of the 30-day pass in my existing cost, and the remaining I don't have to worry about anything because it's done. But it's not complete yet. When we had bought a 7-day pass, so my 7 days were secured, but still 8 to 20 was still not there. Still I'm standing at 8, thinking about what to do. Again, 3 options. Let's buy a 1-day pass. 1 day secured, 1 day is gone. Added 1 day cost, cool. Remaining one is 1 day only, which is 20, but still, I just write it. I'll look at it next. Again, standing at 8, I have again option. Let's buy a 7-day pass. If I buy a 7-day pass, from 8 to 14, it's secured. It's super secured. But you can see, I have traveled only 8. So, but still, I just put in my mind, okay, I have bought a 7-day pass. I added its cost. Remaining part is 20, which I have to worry about next. And I added my existing cost. What if I buy a 30-day pass? Oh, no worries. My whole rest of part is secured, which is a 30-day pass. And like so on, every again, you can just go down. At every step, you'll just have 3 options to think about. 1-day pass, 7-day pass, or a 30-day pass. Firstly, for every day, you have 3 options. If you have 365 days, 3 options. N days, 3 options. For every day, you have 3 options. 1 day, 3 options. 2nd day, 3 options. So 3 into 3 into 3 into 3 into 3 up till N days. 3ish power n exponential. Oof. Can't happen. Can we think of something? Do you see something here? Something special which happened? When I bought this pass, you saw. Again, I had to query the same thing. Okay, here and here, I bought the pass. But the remaining part which I have to think about was for the remaining 20. Or it could have been maybe something more bigger. So you could easily see, okay, again I have to do the same repetition for the same sub problem. As we know that we have got a repeating sub problem. Whenever in recursion you get some repeating sub problem, what comes to your mind? If it is not DP, if it's your girlfriend, sorry, you have to think less about your girlfriend. You have to think about DP. Whenever the sub problem is repeating, you can just memorize it. As simple as that. What was the sub problem? Sub problem was, okay, what is the cost for the sub part? Okay, what's the optimal minimum cost? So my sub problem was the minimum cost of that sub problem, which means the sub array of days. So I just need to optimize it. I can just use a DP. DP is nothing but you just don't have to compute that same thing again and again. You can just put it in some array or something, and you can just grab that value from there rather than bringing calculating the value again and again. It is what a DP does. So basically my DP of I, it will store what is the minimum up till my ith index. I can have, okay, up till this particular 8, what is the minimum value so far I have got, which is actually, it can be this, it can be this, it can be anything. I'll just see how it is done. But I just storing, okay, what's the sub problem minimum I could get, minimum cost or minimum dollars I could get, because I just wanted to get ultimately minimum number of dollars. Cool. So one thing we got to know, okay, we have to memorize it. Recursion can't work. We have to apply DP or something. Let's see how it will done. It's pretty easy. It's exactly the same how I showed you above recursion, how it was working. So although you can just write recursion and just apply memorization and you would be good to go, but still I'm showing you the proper DP approach in which you start from scratch and you intuitively know, okay, how it is working. Let's see how. So basically, if I'm standing at a particular day, what option I have? One option is, if I'm standing at 8, one option is I buy a 1-day ticket. what if I had bought a 1-day ticket? So now I have to worry about the rest. So basically, let's say you have answers for the previous part. You have the answers. Don't worry about that. Just think, okay, you are standing here, you buy a 1-day ticket. So firstly, you have to pay the cost of 1-day ticket. I have represented it as $1, but mark it, it is not $1. It is the cost of a 1-day pass. Okay. So I have just covered. Okay, I have standing here. Now, what was remaining? I just secured my today's trip. What about the rest of the trip? So my rest of the trip answer would be brought out by TP of remaining part, which means 3. As simple as that. Because it will just bring me out what is the cost, because 1 day is covered. Now the remaining days were before it. So it will bring the answer, which means the minimum answer to reach up till index 3. What if I would have bought a 7-day pass standing at 8? At 8, I bought a 7-day pass, which means my previous 7 days are covered. Up till 4, I am covered, which means I have to think about, okay, if today I bought a 8, if today at 8 I bought a 7-day pass, I have to now think about what could have been the minimum up till this point, which means firstly the cost which I have to pay for this 7-day pass, but my all these days are secured, so I have to worry about the day before index 0, including that index. So my TP of 0 will bring me out the minimum cost required up till this particular point. Cool. Again, if I'm standing at 8, I have one option. What is one option? I bought a 30-day pass, so my previous 30 days are covered because of this pass. So what is this cost, which is 30 days plus if I go back, then I have completed. So it will be just landing to -1 index, but actually we don't have -1. So we'll just write an if condition. Okay, it will just give us a 0, which means that no cost is added separately because nothing is there before it. So you can easily see that, okay, at every point I just get 3 values of DP, right? By grabbing one pass, 7-day pass and 30-day pass. I just need minimum because I want the minimum. So I just grab the minimum out of all these 3. For I index, I just find out, okay, what's the 1-day pass value, what's the 7-day pass value, what's the 30-day pass value. I'll grab the minimum and I'm just good to go. It is as simple as that. Just implementing the same thing via what we said. I'll just write down the exactly same thing. How? See, firstly, I just initialize my array of DP. Cool, no worries. I just grabbed, see, as I showed you, right? So if I am standing here, if I'm standing at here for index 1, so I have to look, if I am grabbing a 1-day pass, so I have to look back, just back 1 day, right? So if I just start my array with 0, so I have to write multiple if conditions. So I just grabbed, okay, for the first day itself, whatsoever is the minimum cost between pass 1, pass 2 and pass 3, which means pass for 1 day, pass for 7 days and pass for 30 days, I just grab that minimum value and it is for my first day, which is DP of 0. I'll start from 1 up till all the rest days and I'll just compute again and again. Here I will just find out. What I'm finding out here is the last 7 and the last 30. What it actually means is it was the last 7, it was the last 7, it was the last 30. Which means if I'm standing here, what I have to actually worry about, which means that, okay, my 30 days are covered, my 7 days are covered, what is before that? I have to worry about that only. So it will just grab me that last day, which I have to worry about. Ultimately, my cost standing at today, if I grab a 1-day ticket, will be nothing but the cost of the 1-day ticket plus whatsoever have been optimal minimum answer up till the I-1, because I-1 is nothing but just 1 day before. So it is a 1-day ticket cost. What if I buy a 7-day pass? So a standard just if condition, if my last 7, which means, see, as you can see here, right, I just landed to -1. Here I landed to index 0. So I just marked short, okay, I'm not landing to -1 because I can't access -1 index. So it's just that, okay, I just grab the minimum, which means, see, it is grabbing the minimum from above, which means 1-day ticket is being compared with the new ticket. The cost of 7-day pass plus the cost minimum so far from that last 7 value. If it is not, then it is simply 0, as I showed you guys. So it is just adding that 0 here, just else condition, because it is 0. Same, exactly same for this, my last of 30. Here there's just a, here just the cost is changed. It is also exactly like here is last 7, here is last 30, and also it will be 0 if my DP is -1, because it will be added as a 0. It is actually the very simple DP approach for this problem. Next to this problem is n into 30 in worst case for time, because for every n it is possible that you are going back. As you can see, you are going back if the array is something like very consecutive, which means 1 2 3 4 5 6 7 8 up till essays, like so on. So for every, let's say for this, you are just moving back, and like this again and again 30 steps back. So it can happen for every index. So in worst case it's n into 30, and as we are using an array separately for the DP storage, so it is O of n. But if you just clearly see, okay, if you think okay it's good for you, but it is not, although we have optimized a lot, but still it can be optimized. Let's see how. It's very simple. If you see the code pretty clearly, then I'm just using DP of I again and again. I'm never using I -1, I -2, I -3, something like that, which means only one variable is more than sufficient to actually give me the answer. I'm just using one variable. So why to actually store this whole particular array? Nothing is required. Thus, I can just use one variable for this storing part, and I can just return that one variable. If also, you can just see one thing. I'm just moving on to the last day. So for, if let's suppose if 1 2 3 4 5 up till let's say 6 7 8 9 10 11. So for this date 7, 1 2 3 4 5 6 7, right? It is, let's say, like last day. If I land onto 8, it is for sure that the last day would also be more than this. If I land onto, let's say, this 10, it is for sure that the last day would be actually more than what had been for previous, which means for 8 and for 9. So always it is just last, which means this last, we don't have to compute it again and again, moving from I. I don't have to start back again and again. I can just, for this particular I can just start moving from here itself, because every time my I increases, it can happen that okay, I add other things, but still it might increase, might not increase. As simple as that. For this particular index I just start from the end and I just keep on checking, because it can't go back. It will only go in one direction, because if it is increasing, it will also increase, not decrease. So why to compute it again and again? I can just move on going. I can put it in a queue. I can just move on going in the queue like this. Let's see, it is also pretty simple. Exactly same thing what we implemented above. Here I'm just using a queue to grab whatsoever is not required. So basically for this, let's say 8, my 1 2 3 4 5 6 7, so only all this is required. I just remove this from the queue, and now it is in my queue. 2 3 4 5 6 and 7 and 8. For this next 9, what will happen is my only this queue is required. Again I'll check if this 2 plus 7, if it is actually more than my 9. If it is, then I'm good. If it is not, then actually it is 9, which is equal to 9, which means okay, it is not the 7th day, so I have to remove it. And ultimately for my 9, if I'm standing at 9, so it is the last 7th day, which means 1 2 3 4 5 6 and 7. As simple as that. So I just, as I move on, as I keep on moving in the index, I just start removing all these elements from the queue to actually land to this last 7 or the last 30. I just did the same thing, used a queue, simple queue in a pair where pair will store a date, which means let's say it will store the 5 and also the minimum cost so far to reach up till 5. What we have been storing for a array of DP. That is it. And ultimately I just start removing those values. What I will do now is, as I'm standing here, so ultimately it also needs to be pushed because in future someone has to use it. So I'll just also push it in the queue, considering it as the last 7 and the last 30, which means if it is the last 7, so if it is the last 7, then it is 9 is the day, and the cost, because I am choosing as a 7-day pass for it, and the rest of the 9 days are covered for it, which means that the days up till what it has found and the existing cost. Existing cost was this cost. I'll show the variable which we have been using to replace my EP of I is the cost variable. So the cost variable, if last cost variable for this was this, I am standing at 9 now. So for this 9, I'll just store, okay, cost is existing cost which I had to incur, plus if I use this 7 pass, my rest 7 days will be covered, and it will be the cost if I'm standing at 9 and use a 7 day. So for last, if anyone calls in future for the last 7, it will give me this particular cost because the rest of these 7s are actually covered. And thus you can actually see I just push in the last 7 and the last 30. I get the cost, which is the minimum of the 1-day pass, a 7-day pass, and a 30-day pass. 1-day pass actually a cost, existing cost. This is the cost, existing cost, plus as you are using 1-day pass, so it is just the cost of 1-day pass, which is cost of 0. For this 7-day pass, I just landed on to the last index, which is the 7. It will actually have the 7-day cost. So I just grab that, and I just grab the 30-day pass. If you see, the complexity is just O of n because you are just moving on in the whole array just once. In the queue also, you are just moving one step ahead and removing from one step ahead, removing one step. So in total, you are moving in queue only once, not like this, list this. So it is O of n space. As you can easily see, we are using a queue of length at max 30 because last 7 days can at max be 30 days. So it is nothing but a queue at max can go up to length of 30 or a max length of 7. So it is just O of 1 space. By this you have got the complexity super reduced. I hope that you guys liked it. All the codes of C++, Python, Java, everything is down below. You can just see the code and notes. Every notes I've shown, it is exactly in the below comments also and description also. I hope that you guys liked it. If yes, then hit the like button and see you next video. Goodbye, take care.